Right, so today, as Yolanda's already told us, we're looking at adding and subtracting fractions. So that's what we're going to start with here in sort of our conversation as we get going. Now, guys, the very first thing that we need to know is that in order for us to add or subtract fractions, we have to have something in place in order for us to do that. And what that is you can call it the golden rule, whatever you want. That thing that we need, that we have to have, we need an LCD. Now, LCD stands for lowest common denominator. So it's the smallest number that both of or all of your denominators can divide into. And we have to have a lowest common denominator in order for us to add or subtract fractions. Our denominators have to be the same because we cannot compare or add or subtract our fractions if they aren't. So the first thing that we always check for or always do is find an LCD or a lowest common denominator. Now, what you can see in these two examples is that I already have, or the denominators are already the same. And I've done this just so that we can explain and explore what we're doing. So 5/7, I've got 5 of 7 blocks colored in. It's not very good coloring in, but anyways, plus 4/7, so plus 4 out of 7 blocks. Now, because the denominators are the same, because they were both a denominator of 7, I can easily go and add them. I've got my 5 blocks, 4, 5, plus my 4 blocks, 1, 2, 3, 4, and I get a total of 9 colored in blocks. 9 out of my total 7. Now, I could only do that. I could only add my numerators because my denominators were the same. All right. So in order for you to add or subtract fractions, and this is what this block is saying here, in order for us to add or subtract fractions, we have to have that lowest common denominator. Our denominators have to be the same. So the same thing happens when we subtract. Nothing changes. I've got 5/7, so my 5 blocks over here, minus 3/7, so minus my 3 blocks. If I take away 3 blocks from my 7 blocks, I end up with, from my 7 blocks, from my 5 blocks, I end up with 2 left over. And so my 2 is my numerator. But again, I could only do all of this because my denominators were the same. And so very, very important, underline, highlight, make this note huge. You have to have a common denominator when you are adding or subtracting. When we multiply and divide, we don't care about a common denominator. It is only when we add or subtract. And so as we start to do these examples, we are always going to be looking for a lowest common denominator. All right, I'm just going to wait here in case you want to take a screenshot. If anyone has any questions, you may now raise your hand to ask me your questions. Otherwise, we're going to have a look at some examples. Yes, there's a question to zoom it smaller. I hope that helps. Okay, a couple more seconds.
Sorry, teacher Sam. I can hear, but sometimes I cannot hear. So just be away.
No, don't worry.
Thank you.
Alrighty, guys. I'm hoping we have those screenshots. Let's have a look at some examples here. Okay, now we want it bigger. Right, it was smaller. Here it is bigger. Take those screenshots, and then we're going to have a look at some examples of adding some fractions. Ooh, I can't believe it's only Wednesday. Alrighty, guys, let's have a look. So our very first example we have here is 2/3 plus 1/6. Like I've said to you, the very first thing that we want to do before we even start stressing about adding or subtracting, the very first thing we want to do is we want to find an LCD. Now, there's lots of different ways to think about an LCD. Some people are comfortable with it and can look at that and know automatically what their LCD is. But if you struggle a little bit with the LCD, here's the trick that you use. So you take your two denominators and you list their multiples. So 3, 6, 9, 12, 15, 18, and so on. And then I go to my denominator of 6, 6, 12, 18, 24, and so on, so on, so on. Now, once you've listed a couple, you need to find the smallest one that's common to both. And here, the smallest number that is common to both of them is 6. And so that means my LCD is 6. That now means I know what I need to change my denominators to. So guys, in the chat, I really need us to focus because I have just explained in this sort of section here what an LCD is and the fact that we are about to change the denominators to make it the LCD. So guys, I really, really need you guys to listen, all right? Otherwise, this isn't going to work very well. So LCD, lowest common denominator, and I'm about to show you how we change our denominators to make them the LCD or to make them the lowest common denominator. So now we know what our LCD is, and now we go and look at our two denominators. In the first fraction, I need to make that a denominator of 6. And so that then means that I now need to do my second step, which is make my denominators the LCD. Now, in order to make your denominator the LCD, you are going to multiply those denominators by something. So I need to go and ask myself, what should I multiply 3 by to make it 6? Well, I know that 3 times 2 gives me 6. Let's actually do it on the other side so it's not so squished. But if I'm going to multiply my denominator by something, I have to multiply my numerator as well. What you do to the top, you must do to the bottom. So what we do to the top, or rather to the bottom, we must do to the top. All right, so you can't only multiply your denominator, you have to multiply your numerator so that we're keeping this fraction equivalent. We're keeping it meaning the same thing. So now I can go and do that multiplication. 2 times 2 is 4, and 2 times 3 is 6. Whoopsie, sorry, is 6. I don't need to change the denominator of my second fraction because it's already 6. It is what I want. And so we've got 4 over 6 minus 1 over 6. Now, because your denominators are the same, this actually means that you could write this as 1 fraction of 4 minus 1 over 6. And so as we go, not minus, plus 1, I'm losing my mind, 4 plus 1 over 6. And so that common denominator allows me to write this as 1 fraction. Now all I need to do is I need to do my third step, which is to simplify. Now when I say simplify, this is now where we do our adding or our subtracting. So here we're going to say 4 plus 1, which gives us 5, as a lot of people are saying on the chat, which is awesome, over my LCD or my original denominator of 6. Now guys, very importantly, we always need to check if we can simplify. Sometimes you can, sometimes you can't. And the way we check if we can simplify is if we can divide a number into both numerator and denominator. So I need to ask myself, is there a number that can divide into both 5 and 6 without a remainder and isn't 1? Well, the answer is no. I can't divide anything into both 5 and 6 without a remainder. So this 5 over 6 is as simple as this answer can get. So I can stop there. But if I can simplify my fraction, I have to simplify my fraction. We always want our answers in the simplest form. All right, so I'll leave that there in case you want a screenshot. And then I'm going to get you to try the second one by yourselves. Okay, a couple more seconds to screenshot. Right, so what I'm actually going to do is I'm going to make that a little bit smaller so that you can see what we did. And I'm going to show you B at the same time. So let me just move B up. So there's question B. You can see how we did question A. You can see the 3 steps that we need to follow. So what I want from you guys is to try B. Your answers go in the chat. I don't want any hands raised. I will ask for hands in a second, but I want you to try B for me. So figure out what your LCD is, make your denominators the same, and then check and see if you can simplify, and then check if you can simplify your answer. Remember, if you're struggling to find an LCD, list out the multiples and find the smallest one that's common. Okay, so you've got those 3 steps there for you. You can follow those and hopefully we will get to the right answer. And remember, guys, you're welcome to put your answers there on the chat as Kopano and Leila have done. Keep them coming. I would like to see these answers. Ooh, I'm exhausted. Remember, double check if you can simplify. Make sure that you have made your denominators the same. Make sure you've multiplied bottom and top. Alrighty, if anyone wants to raise their hand to explain it, now's the time. Whoops, yeah, sorry. Okay, Didn't-le, do you want to explain for us?
Ma'am, I said I first got the LCD 36912 and for 4 is 4812. So the lowest common denominator was 12. So I said 2 times 4 and 3 times 4. And then the next one I said 1 times 3 and 4 times 3. Then I got for the first one, which is 2 times 3 equals 8 over 12 plus 3 over 12, which equals to 11 over 12.
Excellent, well done. Right, so guys, exactly. We find our LCD was 12. We make the denominators the same, which means we've got 8 over 12 plus 3 over 12. And that therefore means we can write it as one fraction of 8 plus 3 all over 12. And we know that 8 plus 3 is 11. And so we've got, whoops, I don't know what happened there. Sorry, let's try and fix that for a second. And so 8 plus 3 is 11. We've got 11 over 12. And that is our answer. Now, what we need to be mindful of is the fact that we always want to check if we can simplify. Always, always. We double check this. There's nothing I can divide into 11 and 12 to simplify it further. And so this is my final answer. Right, so I'll stay there if you want to take a screenshot. If you have questions, now is the time to raise your hand. So Leila and Guleto, your hands are up. So I'm going to assume they're questions unless you lower them. But otherwise, guys, if you do have questions, now's the time to ask. And remember, be as specific as you can. Guguletu, what is your question?
Hi, ma'am.
Hi.
Ma'am, in terms of like, let's say a question like this is in the test. Is it possible, like, is it part of the rule book that we can multiply with different numbers for the different fractions? Like here it's 2 over 3 and then it's multiplied by 4 and 4. And then the next plus 1 over 4, we multiply by 3. Is it like part of the rule book or is it wrong? Because
No.
I'm quite lost.
So we can multiply by different values. The reason we can do that is because we want the denominators the same. Now, if the denominators are different, it means that I'm going to have to multiply by different things in order to make them the same. But if you have a look at us, I don't know if it would be the first or second step, but if you have a look at this step over here, if you take 8 over 12 and you simplify it, you can divide both of those by 4. So that gives you 2 over 3, which is the original fraction. If you take 3 over 12 and you simplify it, so you divide by 3, you get 1 over 4, which takes you back to the original fraction. So you haven't changed the meaning of the fractions. You have just found equivalent fractions by multiplying by the 4 and by the 3 in order to make your denominators the same. So you absolutely can times by different things because the whole point is to get the denominators the same. Okay, so Google it, I hope that makes sense. Otherwise, guys, remember, you're welcome to put questions or follow-up queries on the chat. Okay, Maduna's put on the chats about cross multiplication. That's absolutely fine. It does become a little bit more complicated when you have more than 2 fractions. So just bear that in mind. But when you've just got 2 fractions that you're working with, that method does work. So that is fine. Just bear in mind it does become harder when you've got more than 2 fractions. Alrighty, guys, so let's have a look at our next example where we start to subtract. Ooh, a little bit excessive. Right, so like I've said to you, just because we're subtracting, it doesn't mean that we're like the method doesn't change. All right, so when we are going to move to our subtraction operation, we do exactly the same thing. We start by finding our LCD, we make the denominators the same, and then we simplify. Now, Leila, I've seen on the chat that you have another way to find the LCD. If you want to type it out on the chat, we can have a look and see if we all agree. There are other ways to do it, absolutely. This is the way I find easiest, but obviously if you guys have ways that you find easier, that's what you must do. Right, so guys, step number 1 in this question, LCD. So let's list our multiples. We've got 8, 16, 24, 36, and so we keep going. If we list some multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, etc., etc. Now, I've stopped there because I can automatically see that the smallest one common to both is 24. And now this is what Leila has just said in terms of sometimes a way to just find a common denominator is just to times the 2 denominators together. 8 times 3 is 24. So that's absolutely fine if that's the method you use. Otherwise, we look at our multiples. It's often very much the same thing. So we want to make both of these denominators 24. If I times 8 by 3, I'll get 24. But what I do to the bottom, I must do to the top. If I times 3 by 8, I will get 24, but what I do to the bottom, I do to the top. And so what I now have is 3 over 24 minus 16 over 24. I have made my denominators the same. And only once I've done that can I now start my subtraction. Denominators. Now remember, guys, because they are the same denominator, you can write it all as one fraction if you want. So 3 minus 16 over 24. And we know that 3 minus 16 is a negative 13 all over 24. Again, double check if you can simplify your answer. Again, in this case, I can't simplify it. But guys, if you ever want a quick way to check, if you type it in onto your calculator, so where are we at? Negative 13 over 24, and you push equals, your calculator automatically gives you the simplified answer. So because it's just given me back negative 13 over 24, I know that's my most simplified version of the answer. If it gives you back something else, you write down the something else because that means it's simplified. Right, very nice. I saw lots of negative 13 over 24s coming in on the chat, which is amazing. Well done. Rotunda, do the product of its own. I'm not too sure, Rotunda, what you mean when you say you do the product of its own prime number. If you can maybe explain that a little bit more, I can understand. I feel like maybe my brain's just a bit slow today. But let me know, and like I say, we can definitely chat. Right, so guys, again, I want you to try B here. I'm going to leave example A up just so that you can see how we did it. I want you to try B for me. So we've got 4 over 9 minus 2 over 3. Remember, find your LCD. Remember to make your denominators the same. And remember, only once you've done that, can you then go and simplify. So only once you've done that, i.e. find your LCD, can you add or subtract. Right, be careful of your signs. Make sure you've simplified. How does the number become? Okay, so your username right now is user. So user 1, your question said, how does the number become a negative? I'm assuming you mean the negative 13 over here. If you go to your number line, whoopsie, sorry, number line. I made some choices here. Okay, doesn't matter. So I'm sitting at 3. I want to subtract 16, which means I need to move down my number line. So when I subtract 16, I'm starting to go into my negative integers. And so that is why my answer is a negative 13, because I've moved down my number line. And so my answer is now moved into the negative region of my integers. I hope that makes sense. Answer to the question of how long our lessons are, remember, the lessons are always an hour long from 6 until 7. Right, would someone like to raise their hand to give me or to explain how they got their answer? Wandle, do you want to help me out here? There's a little pop-up to unmute yourself. Sorry, I'm not. Okay, there we go.
Afternoon, ma'am.
Afternoon.
Ma'am, so I said 4 over 9 minus 2 over 3. Then I found the LCD by saying 9 times 3. And then the LCD was 27.
Okay.
So then I said equal to, and then I said 9 times, since 9 times 3 was 27, and then said 4 times 3, since what you do at the bottom, you do at the top. And
Good.
then I said 4 times 3, which gave me 12.
Good.
And then I said minus over 27, since I already know the LCD is 27. And
Yeah.
then I said 2 times 9, which is 18 over 27.
Okay. Cool.
And then so then I said equals 12 minus 18 over 27 as one fraction. It gave me the answer of minus 6 over 27. I then found the number that can divide into both the numerator and denominator, which is 3. And then I then simplified it into minus 2 over 9.
Excellent. Well done.
Thank you, ma'am.
Right, now guys, this was a really nice explanation of a way to do it where sometimes the denominator you pick isn't necessarily the lowest common denominator, but it is a common denominator. So you have made the denominators the same perfectly fine because of that whole multiplying your denominators together, which is cool, as I've already said. But we always need to double check if we can simplify, and that's what Lwandle said there. Once he got that negative 6 over 27, the check was to simplify. Now you don't have to do this way. If you, oh golly, sorry, now I've turned my video off because apparently that's where I'm at this moment in time. Alrighty, so Another way that you can do it is you can say that your LCD is 9. And so you could say, okay, 4 over 9 stays exactly as it is, but the 2 over 3, I'm going to multiply top and bottom by 3. So you will end up with minus 6 over 9. And so because your denominators are the same, you've got 4 minus 6 over 9. And we know that 4 minus 6 is negative 2 over 9. It gives you exactly the same answer. And so this is why I'm saying don't stress if you found another common denominator that isn't the lowest common denominator. If it's not the lowest, all it means is that you have to do the simplification step, which I've told you have to be checking anyway, so it doesn't matter. So if you use the LCD of 9, you will get exactly the same answer. A lot of people are putting there on the chat negative 6 over 27. Remember, that is not your final answer. Negative 2 over 9 is your final answer. You have to simplify. Okay, if you don't simplify, you're going to lose marks, and we don't want to lose marks for something silly like that. Right, so I'm going to leave this here like that in case you want to screenshot both of them. And then while we are waiting for everyone to screenshot, now is the time to raise your hand for questions. Didn't yes, the final answer is negative 2 over 9. That should be your final answer. And yeah, sorry, I don't know what I was trying to say. Wonke, question?
Yes, ma'am. I have a question. I wanted to ask, is it possible to get the answer wrong if you didn't write all of the multiples?
I mean, you don't have to write all of the multiples as long as you write enough to find a common multiple. So for example, back up here, I definitely have not written all of the multiples of 8 and 3 because that just goes on forever. But I wrote enough to get that 24 was the common one. So you don't have to write them all. You just have to write enough until you've got the same number in both of them.
Yes, ma'am, I understand. Thank you.
Okay, good. All right, again, this is user 1. Please let me know what your name is so that I'm not calling you user 1.
Hey, ma'am, this
Hi.
is Sasanda from the other class.
Okay, Susanda, yeah?
Yes, ma'am. I wanted to ask about the way that we subtract because we're supposed to, if the other number is bigger than the, okay, like you see them like 12 minus 18.
Yes.
So if 12, like if the number is smaller than the other number, do you have to drop down into negatives?
Yes, exactly. So that's a much better explanation in terms of what I was trying to say earlier. If your number that you are starting with and then you're subtracting is smaller than the number you are subtracting, you are going to end up with a negative value because you've only got 12, but now I want to take away even more than 12. So it means I'm going to end up with a negative answer or a negative value. So yeah, definitely.
Yes, ma'am.
Okay, Sandra, well done. Alrighty, guys, very nicely done. We're going to take a little brain break because you guys have done really nicely and you've worked very hard through these 4 examples. I'm hoping you've all got your screenshots. I'm going to wait here for 3 seconds and then I'm moving on. Right. So brain break today. A little bit different to what it usually is, just because it's not one of those solve emoji thingies, but this is still a cool one. So this is a magic square. I feel like we've done a magic square before, but I also could be completely wrong and I could be thinking of one of the other classes. So this is a magic square. A magic square is basically that every single row, column, and diagonal. So let me just show you what that means. Every single row, every single column, and every single diagonal must add up to the same value. And so what we want to do here is we want to use that fact to work out these colorful blobs. So we've got a blue blob, green blob, purple blob. Let's just change that to a red blob because that's a weird looking color. A brown blob and a yellow blob. we want to know what those values are. So my hint to you to start this off is try and find a complete diagonal, column, or row so that you can first figure out what the sum should be across all of them. And then you can start to fill in your missing numbers. So that's my hint. I'm going to try and color coordinate this as best I can. So we've got a blue blob. Here's my blue blob. A green blob. I don't know why I'm calling them blobs. Shame, they're little circles. A purple blob, and I called it a blob again. A purple circle. A brown circle. Oops. The red circle. And the yellow circle. So we want the values of all of those circles there. So have a think. You guys can put it on the chat. So just say blue equals green equals purple equals. And we'll see as we get some numbers. But let's have a try. Guys, remember we're focusing on fractions today. So remember, if you've got questions about other topics, try and join the lesson early and we can help you before class starts. So my hint again, try and find one complete diagonal or one complete column or row or whatever, and figure out what the sum should be so that you can go and work out the rest. Up Lele, it must be a number. We don't want symbols. All of those circles represent a number that we don't know. Oh, sorry, that was a weird noise. I'm hoping we're all trying this by ourselves and we're not just copying each other's answers. Right, so if we're still struggling, there is one complete section. So if you do this diagonal over here, if you add 4, 6, 11, and 13, you will figure out what your sum should be across all columns, rows, and diagonals. So I would start there and then see if you can work out what the missing values are. I'm not seeing any correct answers just yet. Just trying to double check as we go along. Oh, great. Okay, let's just quickly double check our sum. 4 plus 6 is 10. 10 plus 11 is 21. 21 plus 13 equals 34. So that means every column, every row, and every diagonal must equal 34. So hopefully that helps you figure out what those numbers are, because those ones on the chat are not, I didn't see any correct answers there. I'm going to give you guys another minute or two. Now we're starting to get some right answers. That's good. Okay, we're getting there. Slowly but surely. I'm just like having to look up and down at my answers. Okay, so far I've seen correct answers for blue and blue. Alrighty, guys, I think let's take a screenshot of this and we'll try this again on Monday. So take a screenshot and try and figure out what your missing colors are. Remember, the sum is the same. It has to add up to the same value. That's what it says over here in the information. So we're not multiplying, we're not dividing, we are adding. And I've given you what it should all add up to. I've told you that it should all add up to 34. So take your screenshot. We will look at this again on Monday, although as I'm saying this, let's just have a look if I agree with all of these that Sean has put there. Before I just jump the gun here. Nice, Shana, do you want to, that's absolutely 100% correct. Do you want to raise your hand and tell us how you got all of those? Okay, tell us, well done.
Thank you, ma'am. The diagonal answers, I added them all up and I got 34. And then basically for the, I'll start with the blue blob or the blue circle. I added 13 and 2 and 3, and then I got 18, and then I said 34 minus 18, and then I got 8. So then I knew that the blue blob equal to 8, and then I wrote it down. No, 16, sorry.
16, yeah, good.
Yeah. And then I knew that it equaled to 16. And then for the green blob, I said 5 plus 11. No, I said 13 plus 12 plus 1, which equals 26. And then I said 34 minus 26 is 8. So then I knew that the purple blob equaled 8.
Good.
And then, yeah, and then for the green one, I said 8 plus 11 plus 5. And then I got 21. And then I said 34 minus 21, which equals 10. And then I wrote that down. And then, for the green. And then for the brown, I said, obviously 16 plus 5 plus 4, which equaled 25. And then I said 34 minus 25, which gave me 9. Good. So then, for the yellow, I then said 4 plus 14 plus 1, which equaled 19. And then I said 34 minus 19, which equals 15. And then for the red, I said 2 plus 11 plus 14, and then I got 27. And then I said 34 minus 27, which equals 7.
Excellent, well done. Okay, so guys, that's how you do a magic square. Sorry, my numbers are all disappearing. That's how you do a magic square. You need to make sure that every column, every row, and every diagonal that you have adds up to the same number. And the number that we were working with here was the number 34. So they all had to add up to 34 in this case. Nicely done. All right, so that's a magic square. Every now and then I do throw a magic square there because it's quite fun to do. This was quite a hard one. Usually, the slightly easier ones are only 3 numbers by 3 numbers. This was a little bit harder because there were more numbers, but very nicely done, guys. Oh, it's about bedtime. Alrighty, let's have a look at another example. Now where we have 3 fractions and mixed operations, which doesn't change the situation that we're talking about. It just means that we now need to be careful. And now this is where I'm saying the cross multiplication idea might become a little bit trickier. All right, I'm glad we're all being so supportive on the chat. That's amazing. That's what I like to see. Right, so if you have a look at this question, we've got 3 over 12 minus 1 over 3 plus 3 over 4. So I'm going to start you off. I'm not going to do the whole thing. You're going to try this by yourself. But let's start off by deciding what the LCD is. So if I look at my denominators, I've got 12. So if we list the multiples, 12, 24, 36, 48, I'm going to stop there for now. I've got the denominator 3, so 3, 6, 9, 12, 15. Again, I'm going to stop there for now. And then I've got the denominator 4, 4, 8, 12, 16, etc., etc. Now we want to decide what our LCD is. Remember, we want the smallest number that now appears in all three of these. And if we have a look, 12 is the smallest one, as Bonolo said there on the chat, that is in all three of them. So now we know that our LCD for this fraction needs to be 12. That's a very aggressive size pen, but anyways. Right, so I've started you off. I want you to finish this off for me. Do not use a calculator. These sorts of questions, guys, in a test, they will tell you to do without a calculator. So do it without a calculator. Try and do it by hand. Obviously, a calculator can be used to check, but you need to show all of your working out. So like I said, I've started you off. I've told you what the LCD needs to be. Give it a try for me. Remember what operation you're doing where. So there's 3 over 12 minus 1 over 3 plus 3 over 4. So just be careful of your operations. And remember, once all of your denominators are the same, that is the point where you can start adding or subtracting. Seeing some good answers so far. Let's keep them coming. Guys, remember, you can't just add those numerators as they are. You first have to change them. So you have to do the multiplication at the top and the bottom to get your LCD. So you can't say 5 in your numerator because you are not saying 3 minus 1 plus 3. You need to change the numerators first. Remember to simplify. We always want to simplify. Right, would anyone like to raise their hand to explain how they did this? Right, that's looking good, but remember, simplify. Samo, help me out here.
Okay, so ma'am, I took off from where you left us. So then I said 3 over 12 minus 4 plus 9 over 12.
Okay, so guys, just that we all know where that's coming from, I would have to times the 3 by 4, which means I times the 1 by 4. That's where the minus 4 is coming from. And then for the last one, I'd have to times the 4 by 3. And so I'd have to also times the 3 by 3, so plus 9. And that's all over 12. Okay, keep going, Zamo.
And then the answer was 8 over 12. And then I simplified it and divided 8 by 4 and 12 by 4. Then it gave me the fraction of 2 over 3.
Excellent, well done. Alrighty, guys, so there you have it. What we want to do is we want to make all of our denominators the same. So that meant we had to make them all the LCD of 12. And so this is the multiplication I did here. If you want, this would then be 3 over 12 minus 4 over 12 plus 9 over 12. That is essentially what happens when I change all of my denominators. But remember, that means I can write it all as one fraction. 3 minus 4 is negative 1. Negative 1 plus 9 is 8. But 8 over 12 has to be simplified. I can divide both of them by 4, and that gives me my simplified answer of 2 over 3. So be careful with your operations that you're using in your sum or in your expression. Make sure you made the denominators the same, and always double check that you have simplified completely. Right, so this is the only answer you can get. If you got a different answer, either you haven't simplified or you haven't done it correctly. So this is now where you need to be doing your corrections. And as I said, Kuluse, no, don't use a calculator. I said at the start of the question, try do this without a calculator. Right, if anyone has any questions, now's the time to raise your hand. Otherwise, you're taking screenshots. Mavelo, question?
Ma'am.
Yeah.
Is it fine if I can tell you what I did?
Okay.
So basically what I did is, so since LCD is 12, I made all the denominators by 12, right? So after that, after what I did 3 minus 4, which equals -1. Then I plus it by 9, which equals 10.
Okay, so just be careful. If we're saying -1 plus 9, so here's -1, 0. So -1 plus 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's positive 8.
8. Okay, thank you, ma'am.
Pleasure. So guys, be careful when you are adding and subtracting, especially when there's a negative. Because it was a -1 and we were adding 9, we're going from the negative side of our number line to the positive side, but not completely to 10. I started at a negative, so I'm only adding 9, which takes me to +8. It's a very easy mistake to make, so don't worry. Just try and remember to imagine your number line in your head. All right. Yeah, guys, don't worry, we will never forget about the quiz link. We are on it. There is it a bit bigger for those of you asking.